Hello everyone, I hope everyone is safe and doing good. Welcome back to my channel Recorded with Mathematics. This video is a continuation of my ongoing series on functions. So far we have seen the definition of a function, the concept of domain, codomain, range, and also the interval notation that you need to know in order to define the domain and a range of a function. If you haven't watched my previous videos that involved me explaining all these concepts, then I will link it up here for you to watch. So in today's video, we will see in depth about how to find the domain of various functions and the considerations that you need to keep in mind in order to find the domain of various functions. So without wasting any more time, now let's jump right into the video. In order to identify the domain of a function, you need to keep a few things in mind. You need to actually observe the function itself given in the question to understand what and how you need to go about in finding the domain of a function. So the thing is, if they give you the ordered pairs and ask you to find the domain, it will be easy. You just pick up the first values and find out the domain. And if they give you a linear equation or a quadratic equation without any denominator and then they ask you to find a domain, you'll just plug in the values and you will see whether it's satisfying for all the real numbers or not, and you'll just get the answer. But if there is a denominator, that is, there is a denominator that has linear, quadratic defined in it, then in that case we need to ensure that the denominator is not equal to 0, because if it's equal to 0, it will be undefined. And also we need to ensure that whenever they give you a root, a square root or a radical, we need to ensure that the value inside the root should not be negative. Else it will not be valid for real numbers if you consider real numbers as the domain. Right. So these are all a few considerations that you need to keep in mind in order to define a domain. In today's video, we will see various kinds of questions that you might encounter while writing your exams. And we'll see how to go about those questions and find the domain. Okay, the first question is, so we need to find the domain of this function as a set of ordered pairs. So we have, this is the question, they gave you a set of ordered pairs here, and what will be the domain? It's pretty straightforward. We know for a fact that the first values are the domain. So we can say that the first values of these ordered pairs will be the domain. So the domain can be defined as -4, 0, 2 and 6. Right. So this is how you find the domain of a function when you get a set of ordered pairs in the questions. Pretty straightforward and very easy. Just pick up the first values and write the domain. See, -5, 0, 2, 6. This is the domain. Okay, now let's see what happens when you are given a function. Next type is, what is the domain of a function if it's written in equation form? It can be this equation or it can be any quadratic equation for that matter. Okay, so if this is the function x square minus 1. So what do you think are the values of x here? Do you see any restrictions? Do we need to keep in mind that x should not be negative? No, because we have square. So we don't have, and there is no denominator, we don't have to worry about any denominator here as well, right? Because there is no denominator with x in it. So that means it's a plain straightforward function. That means, don't you think if we give any real number as an input, say for example -5, -3, -2, 1, 10, -20, 0, 0, whatever it can be, ultimately when you square this and subtract -1, you will get a real number only, right? So that means all real numbers can go as an input in this function. There is no restriction. Yes, so we can say that the input of this function, the domain of this function will be set of all real numbers that can be represented as -infinity to infinity. Okay, so this is how you find out the domain. So in this case, there is no such restrictions, plain straightforward function, and can be applicable to any quadratic. You can also say that the domain will be real numbers when f of x is 5 minus x plus x cube. Anything, it's just a plain equation. Okay, now let's see how to tackle the situation where there is a denominator with x in the function. So the next step will be for you to find the value or find the domain of a function involving denominator. So in here, say for example, this is the function. Okay, this has the denominator x. So we need to ensure that this will not become 0. What do I mean when I say that denominator should not be equal to 0? That means, when will this denominator be equal to 0? When x is 2. Right. So that means if you plug in x here, you'll get something by 0, which is undefined. We don't want that case. What we want is, we want to exclude that case from the domain, the interval itself. In order to do that, what we do is, usually whenever you encounter such situations, what you do is, you put the equal to 0 and solve for x. First you do that. So then you will identify what all values will be present for x such that the denominator is 0. And then after you get the x values here, if it's a linear equation here, you can say a quadratic here. So whenever this is a quadratic equation, you get two values wherein the value of x will be 0. You need to exclude those two values. When it's cube root here, see whatever and wherever x will become 0 in the denominator, you need to remove those values and exclude them from the domain. So in here, we put 2 minus x is 0. So what will x be? 2. That means this value, when you put here, it will become 0, right? So the domain should not consist this value. The domain of a function f of x expressed 1 by 2 minus x will be all real numbers, right? All real numbers but 2, correct? You put any real number, you'll get the value until and unless x is 2. That means except 2, any real number you put, it can be accepted as a domain. So how do you write this? You need to exclude 2. In such cases, what you do is, you put minus infinity, comma 2, okay, union 2, comma infinity. This is how you exclude 2. This means that this particular function will take the values of from minus infinity, this to the left corner from there, until before 2, but not 2. That is why we are writing union, because these two are the range, they are the domain except 2. And then until after 2 till infinity, plus infinity. That means, if you say this is the number line, all these values from minus infinity to 2 and all these values from 2 to plus infinity will be possible except 2. That is the meaning of this. So hence the domain of the function express 1 by 2 minus x will be minus infinity comma 2 union 2 comma infinity. That is, we are combining two different intervals here by excluding one term. Okay, so that means all the values that are less than 2 and all the values that are greater than 2 are acceptable to be the domain of this function. So less than 2, x less than 2, if you remember the interval notation from my previous video, this what is x less than 2 and this is x greater than 2. So we are using union to combine these two sets. Okay. So this is how you find the domain of a function wherever you have a denominator. Pick up the denominator, equate it to 0, get the values where the denominator is equal to 0 and exclude them from writing the domain. Okay, next form is find the domain of a function written in an equation form including an even root. This is the root, right? And we know for a fact that this can't be negative, this can't take any, a root cannot have any negative, it will become an imaginary. Right, so that means what we need to do is, we want this entire value to be positive or equal to 0. Am I right? So in that case, whenever you have the root, put the value inside the root as greater than or equal to 0. It's a fact, if you get less than 0 here, you will get a negative value inside the root. It's an imaginary number. So we want this value inside the root to be greater than or equal to 0. Right. Then find the value of x here. What will be x here? 2x is minus 5. X is greater or equal to minus 5 by 2. So that means what? X is greater or equal to minus 2.5. Right? That means in order to get this root, the value inside the root to be positive, the value of x should be greater or equal to minus 2.5. That means the domain of this function can take the values from minus 2.5 because it's equal to till infinity, positive infinity. Okay, any values that is below minus 2.5, that is if it's minus 3, then this root will become negative. Check for yourself. If you put minus 3 in x, it will become 5 minus 6, that is root of minus 1. It's not possible, right? So that is the reason we'll put the value of x starting from minus 2.5, whatever can be the value, you can put it in this function in order to ensure that the value of this root is positive. Okay? So that is how you find the domain of a function written in an equation form with an even root. Okay, now let's see the next form. So the next form is to find the domain of a function using natural logarithm, that is ln. So you know for a fact that log can take positive values, that is greater than 0. I have defined why and everything about logarithm in one of my playlists that I will link it up here so that you can go and understand the definition of logarithm and the usage of logarithm, laws of logarithm in detail. But this is the value, right? And you know for a fact log will take positive values. So whenever you have a log in the function, the natural logarithm in the function, what you will do is you'll take the value inside the log, the brackets value, as greater than 0 because you know for a fact logarithm will be greater than 0. So just put x minus 8 in here as greater than 0 because here the function is log x minus 8, right? And so what will get x is greater than 8, isn't it? So that means the domain of this function will be 8 comma infinity. Any value that is greater than 8 is an acceptable domain of this function log x minus 8. Right, check for yourself. If you put 7 here, it will become log minus 1. If you put 8 here, it will be 0. But if you put 9 here, it will be log 1. 10 here, log 2 and so on. So we get the values from there on. Right? So this is how you identify the domain of a function whenever there is a natural logarithm defined in the function. Now let's see how can you find the domain and range of a function using a graph or from a graph. The last concept of this video is to find a domain and a range from a graph. So this is a graph of a polynomial. Okay, so wherein using this graph, let's now try to find the domain and range. It's very important for you to understand how to decipher or get the domain and range from any given graph for you. Okay, so in here, this is a polynomial, the curve. Now, what is the x-axis here? It starts from minus 5 and there is no boundary as such. It goes on like this. Right. So that means there is no end point to this graph. Assume that this is going on. Okay. So the domain of a function represented in this graph should be the values taken from the x-axis. That is, the graph is starting from this point. This is the start point and it's just going on is what you assume. Okay, this is not the end of the graph from the right axis, right hand side. So it starts from minus 5 here and it will go on until infinity. You will see the x-axis and see where exactly the graph is stopping. In here, it is not stopping, it's just going on like this. Okay, so that is the reason why you can say that the domain of this graph as minus 5 comma infinity, that includes minus 5. This is the domain. If you see this green line here, we are reading the domain from left to right. That's the reason I marked this as the domain. Now, how to find the range? Range will be represented in the values of the y-axis. Here, whenever x is minus 5, y is 5, Whenever x is minus 4, y is some value. Whenever x is minus 3, y is some value, and so on. Right? So that means the range starts or ends at minus 5. Right? Now if you see, the function is decreasing. So that means the largest value of the range is 5, because from 5 the function is decreasing. It is nowhere going beyond the 5 in this graph, isn't it? So how do you write the range now? 5 is the maximum value and it's decreasing, isn't it? We don't know the end limit. So what we'll do? Minus infinity comma 5. So this is the domain and this is the range of this graph of a polynomial. This is how you read the domain and the range. Domain is written from left to side and range from bottom to top. So this is the range. So whatever graph they give you, this is how you read the domain and the range from the graph and determine it. Alright? So I hope you understood today's video. It's a very important video and I've covered all the basic concepts and problems that are involved as a part of finding the domain of a function. They are much more complicated. Things get complicated from here on. However, if you understand these basic concepts, you can apply these concepts to the very difficult problems as well. So if you want me to solve any additional IIT questions on these topics, then please leave a comment down below so that I'll put a dedicated video related to the most difficult problems of domains and range of a function. Alright, so if you like my video, I request you to please like, share and subscribe to my channel and ring the bell notification down below so that you will never miss an update from me. I will see you all in my next video wherein I'll cover different types of functions and we'll take on from there. Until then, please stay safe and be happy. Bye.